Hello friends, my name is Tushar and today we are going to talk about the question iterative in-order traversal of a binary tree. In my last video we looked at a recursive version of in-order traversal of a binary tree. Today we are going to look at the iterative version. So let's recollect what in-order traversal is. In-order traversal is left, visit and right. Basically saying visit everything on the left side of a node, then visit the node or print the node, and then visit everything on the right side of the node. So let's look at this example. 10 is the root of this binary tree. Since 10's left is not visited, we will not print 10. Go to 11. 11's left is also not visited, so we go to 2. 2 doesn't have a left, so we print 2. 2 doesn't have a right, so we go back to 11, print 11, and then go back to -1, print -1. Now we are back to 10. Now we reach 10. Everything on the left side of 10 is visited or printed, so we print 10. And then go to the right and repeat the same process. 16's left is not visited, so if we first visit 16's left, 10's left is not visited, so we go 9, then we print 10, then we print 11, and now everything on the left side of 16 is done, so we print 16, and then 16 doesn't have a right. So this is my in-order traversal for this tree. Again, for recursive version, we relied on programs call stack to do most of the work. For the iterative version, we will have to use our own stack. Again, stack is a last in, first out. So the element going last into the stack is the first to come out of the stack. Let's see how it works here for this example. So I'll create a new stack, and the root is 10. So let's see how it works. First, if root is not null, we put that into the stack and say root is equal to root left, so that's 11. 11 is not null, so we put that into the stack, and root is equal to root left, so 11's left is 2. Again, 2 is not null, so we put that into the stack and say root is equal to root left, so root is null. As soon as root is null, we pop from the stack, we print it, and make root this guy's right. So this guy's right is null, so root stays null. Again, since root is null, we pop from the stack, we print it, and make root as this guy's right. So this guy's right is -1. So -1 is not null, so we push that into the stack, and we say root is equal to root left, so this is -1's left is null. Again, as soon as root is null, we pop from the stack. So we pop from the stack, print it, and make root as this guy's right. So -1's right is again null. Since root is null, again we pop from the stack, we print it, and make root as 10's right. So 10's right is 16. So since 16 is not null, we push that into the stack and make root as root's left. So 16's left is 10. Again, 10 is not null, so we push that into the stack and make root as 10's left, so that's 9. Again, 9 is not null, so we push that into the stack and make root as 9's left, so that's null. So now that as soon as the root is null, we pop from the stack, print it, and make root as 9's right. 9's right is null, so again we pop from the stack 10, we print it and make root as 10's right, so that's 11. Since 11 is not null, we push that into the stack and make root as 11's left. 11's left is null. Again, since root is null, we pop from the stack, print it, and make root as 11's right. 11's right is null, so root stays null. So again, we pop from the stack, we print it, and 16's and then 16 we make root as 16's right, so that's null again. So as soon as my stack is empty and my root is null, I break out of this while loop. So this is my in-order traversal. 2, 11, -1, 10, 9, 10, 11, and 16. How much time would it take to execute this algorithm? Since we visited every node once, the total time will be O of n. How much space would it take to execute this algorithm? the amount of space it will take will depend on the size of the stack, and in worst case the size of the stack will be the height of this binary tree. So that's O of h, where h is the height of the stack, and in worst case the height of the stack can be the total number of nodes. Next, let's look at the code for this algorithm. So this is the code for iterative in-order traversal. Let's quickly look at the structure of the code. So the name of the function is iterative in order. It takes the root of the binary tree and returns void, since we are just printing the nodes of the tree. If the root is null, we just return, otherwise we create a stack of nodes, and then we go into this while loop. With while is true, it means that we'll have a breaking condition inside the while loop. If the root is not null, we push into the stack, make root as root left, and we again go into the top of while loop. We keep doing this till root is null, and then we go into the else condition. If stack is empty, then we break out of the while loop, otherwise we pop from the stack, print out root data, and then make root is equal to root right. Let's work this code with this example here. So I have initialized I have a root is 10, it's not null, so I initialize a stack, and now I go into this while loop. So while true, so root is not null, root is 10, so we push that into the stack, and root becomes root left, so root left is 0. Again we go here, root, we don't go into this else, we go back here. Again root is not null, so we push that into the stack, so 0, and root becomes root left. So that's 5. Again root is not null, so we push 5 into the stack, and we say root is equal to root left. In this case root becomes null. Again we go into the top of this if root is null, so now we go into the else condition. Is stack empty? Stack is not empty, so we come here, root is equal to pop out of the stack, so root is 5. We print out 5 on the console, and then we say root is equal to root right, so root becomes 5's right, so that's null. So we go back to the top of the while loop. Again root is null, so we go into the else condition. Stack is again not empty, so we come here. Again we say root is equal to s dot pop. So we pop from the stack 0. We print out 0. And then root becomes 0 is right, so that's 6. So root becomes 6. So we go back to the top. Root is not null this time. So we push 6 into the stack, and root becomes root's left. So 6 left is null. So we go back to the top of the while loop. This time root is null, so we go into the else condition. Stack is not empty, so root becomes s dot pop. So root becomes stack stop, so 6. We print 6, and then we go root is equal to root right. So 6 right is null. So we go null here. Root is null. So now, again we go top here, root is null, so we go into the else condition. Stack is not empty. So we again pop from the stack, so root becomes 10. And this is popped from the stack. We print out 10, and then root is equal to root right. So 10's right is minus 10. So we go to the top of the while loop. Root is not null, so this time root is not null. So we push minus 10 into the stack. And then we say root is equal to root's left. So minus 10's left, so that's null. Again now we go back here, root is null this time. So we come into the else condition. Stack is not empty. So we pop from the stack, so root becomes minus 10. And we pop it out from the stack, and we print out minus 10, and then root becomes minus 10's right, so that's 11. Root is equal to root right, so 11. Again we go back here, root is not null, so 11 is not null, so we push it into the stack, and root is equal to root left, so 11's left is null. So again we go here, top here, root is not null, so root is null, so we go into the else condition. Stack is not empty, so we pop out from the stack, root becomes 11. We print 11, and then root becomes root right, so root's right is null, so root becomes null. So we go back to the top of the while loop, root is not null, so this time root is null, it goes into the else condition, if stack is empty, stack is empty, so we break out of the while loop. So this is my pre-order traversal. The break condition is very critical. The root has to be null, and the stack has to be empty to break out of this while loop. And my in-order traversal is 5, 0, 6, 10, minus 10, 11. If you want the full working code for this example, go to my GitHub link, github.com, Mission Peace Interview Wiki, and if you want to check out similar questions, go to my YouTube channel, youtube.com, user Tushar2525. Thanks for watching this video.